3.0 We are now entering the most important section of the CCNA, IP connectivity. This represents 25% of your exam because it covers the brain of the network, the router. In this section, we learn how a router looks at a destination and decides exactly which path to take. Objective 3.1. Interpret the components of a routing table. When a router receives a packet, it consults its routing table, which is essentially a map of the network. Let's break down the key parts of that map. 3.1a. Routing protocol code. When you look at a routing table, every line starts with a letter. These are codes that tell you how the router learned about that path. L. Local, the specific IP of the router's interface. C. Connected, networks directly plugged into the router. S. Static, paths a human manually typed in. DEIGRP, an advanced Cisco protocol. OSPF, one of the most common open standard protocols. 3.1b and 3.1c. Prefix and network mask. These go hand in hand. The prefix is the destination network address, and the network mask or subnet mask defines the size of that network. For example, in 192.168.1.0/24, the prefix is the IP part, and the /24 is the mask telling the router that the first 24 bits are the street name. 3.1d. Next hop. The next hop is the IP address of the next router in line. Think of it like a signpost on a highway. To get to New York, go to the specific exit next. It's the gateway to the rest of the journey. 3.1e. Administrative distance. AD. What happens if a router learns about the same destination from two different sources? It uses administrative distance to decide which source to trust more. AD is a trustworthiness scale from 0 to 255. The lower the number, the more the router trusts it. For example, a static route, AD1, is more trusted than OSPF, AD110. 3.1f. Metric. If a router has two paths from the same protocol, like two different OSPF paths, it uses the metric to break the tie. The metric is the cost of the path. A lower metric usually means a faster or shorter path. Think of it like GPS. If both paths are on the same highway, the metric is the one with less traffic or fewer miles. 3.1g. Gateway of last resort. This is the I don't know route. If a packet comes in and the router has no specific entry in its table for that destination, it sends it to the gateway of last resort. In a home or small business, this is usually the path to the internet. If this isn't set and the router doesn't know where to go, it simply drops the packet. Practice tip for the video. To see all of this in action, use the most famous command in networking, show IP route. In your video, you can point out a specific line, such as D10.1.1.0/2490/2172.416 via 10.1.1.1. D is the protocol code, EIGRP. 10.1.1.0/24 is the prefix/mask. 90 is the administrative distance. 217.2416 is the metric. 10.1.1.1 is the next hop. Now that we understand what is inside the routing table, we need to look at the brain of the router. Objective 3.2 is all about the decision-making process. When a packet arrives, how does the router choose the winner among many different possible paths? It follows a very specific three-step logic. Think of this as a filter system. The router starts with the most specific rule and works its way down to the general ones. 3.2a. Longest prefix match, the first filter. This is the golden rule of routing. The router always prefers the most specific path to a destination. Imagine you are looking for a house at 123 Main Street. One sign says, "This way to Main Street, 192.168.1.0/24. Another sign says, "This way to 123 Main Street, 192.168.1.123/32. The router will always pick the second sign because it has the longest prefix match, the higher CIDR number. It doesn't matter how fast the other path is or who told the router about it. The most specific address always wins first. 3.2b. Administrative distance, the second filter. If the router finds two or more paths with the exact same prefix length, for example, two different ways to get to 1.0/24, it moves to the second filter, administrative distance, AD. As we discussed before, AD is about trust. The router looks at who gave it the information. If a human manually typed it in static route, the AD is 1. If the OSPF protocol found it, the AD is 110. The router will choose the path with the lowest AD because it trusts that source more. It's like asking for directions and getting one answer from a local resident and another from a tourist. You're going to trust the local more. Image comparing administrative distance values for different routing protocols. 3.2c. Routing protocol metric, the third filter. What if the router has two paths that have the same prefix length and they both came from the same source? For example, two different paths both learned via OSPF. Now, the router uses the metric to break the tie. The metric is the cost or overhead of a path. OSPF uses cost based on bandwidth, speed. IGRP uses a complex formula involving bandwidth and delay. RIP simply counts hops, how many routers are in the way. The router selects the path with the lowest metric. If the metrics are exactly equal, the router will actually do something called equal cost multipath, ECMP, where it splits the traffic and uses both paths at the same time to increase speed. Summary for the video. To remember this for the exam, just remember the order. Prefix, AD, metric. Prefix. Is one path more specific? Longest mask wins. AD. If masks are the same, which source is more trustworthy? Lowest AD wins. Metric. If sources are the same, which path is cheaper or faster? Lowest metric wins.